Hey guys, welcome back, and today we're going to be building a REST API for a crypto mining pool. So we're going to have two objects here, a wallet and a miner, and each wallet is going to be allowed to have more than one miner. Right, so essentially the miner is going to be the child of the wallet in this example. You can see our endpoints are up here, and this is going to be our different get endpoints. We're going to have some post endpoints. And each of these blocks represent our JSON bodies here. So over here, these are going to be our post bodies. So when we create a new wallet, all we want to do is pass in the club name. And when we create a new miner, all we want to do is pass in the nickname. And then that will create these objects. And these will be our JSON representations here in the orange. These are going to be what we see in the API and what the different attributes or fields that we have to work with. But down here in our database, this is going to actually be how the objects are represented in the database. And as you can see, if any of you guys are familiar with databases or relational databases, we're going to have a primary key and we're going to have a foreign key or a secondary key. And that's just going to point to the ID, in this case, address of the wallet that miner is a part of. So in a nutshell, that's what it's all going to look like. So let's flip over and let's build this thing. So I've just gone ahead and generated a new project here like we've seen before. And this is what the cargo toml is going to look like for this. So we're going to use Saturday like we've seen before. And now we're going to be using this Actix framework, which is going to be our web framework that allows us to create a REST API. So now if we bounce over to our source folder here, let's create some new Rust files. So to start, we're just going to create the object representations of each of these things, right? So we're going to create our REST API ones, and we're also going to create our database objects, and of course the ones for our post requests. So let's start with the miners. We'll go with miner rs, and inside this file, we're going to actually set up our use things like this, because I think this is just kind of cool. And to start, we're just going to use Saturday. And we'll go with deserialize and serialize. And this is where we're going to put our JSON payloads. So now we've seen this annotation before, right? We're just going to do the deserialize and serialize annotation. And we're going to have a pub struct called miner. And again, this is going to be the one that we're going to see in our API. So it's going to have all the fields filled out on it. All right, cool. And as we can see, here's our miner object. And we've got all the same fields here. And here our hash rate that our miner is putting out is just going to be a mega hash per second. Nice. So that's our JSON payload. And now how about our post request for the new miner? Well, let's go ahead and build that. We're going to use the same exact annotation as before. And this time we're going to just do a pub struct of new miner request. And that's just going to take in a nickname as a string like we saw here. Just want to take in nickname. And now lastly, we're going to want to do our database object, which is going to be called a DAO, a data access object. And that's just going to allow us to insert and select different records from our tables in the database. So that's going to look like this. And it does use annotations, but I'm not going to bring them in here yet because we didn't put them in the cargo toml. So I'm going to save that just for now. All right, and we can see that that is also the same as our picture here. So we can see that that matches up with this. Nice, and now let's go ahead and do the same thing for wallet. All right, so there's our struct there for our REST body. And as you can see, that does match up here with our wallet object. So we got all of these blue fields, which are going to come, of course, from the minors that we go and scrape out of the database. And of course, now we've got our new wallet request, just like we saw as well over here. So just the club name as an input. And of course, there's our wallet data access object. And that's going to match up with this guy. So all of our fields match up. We got everything that we want in our API represented by structs. So now we just have to start implementing our API logic. So we'll start with the endpoints that our API is going to have. And then we'll go ahead and create the root of the crate with the actual Actix main function. And we'll see what all that looks like. So to create these endpoints, I'm going to separate miner and wallet like we did here with the structs. And I'm going to go ahead and just create these objects called controllers. If you're not familiar with what a controller is, it's not really a big deal. The important thing to think about right now is it's going to be an object that has REST endpoints. That's all you need to know right now. So we'll start with miner controller.rs. And of course, the other one's going to be wallet controller. And so I'm just going to type in our inputs. And of course, we're going to be using that whole miner module here from the crate. So now let's start defining REST endpoints in our API. So the first one is going to be list all miners, right? And back in our diagram, that looks like this up here. So it's just going to be /miners. So what we want to do is add this annotation. And this is an Actix annotation for a GET request. So we're just going to do /miners. And that's it. And now Actix is an asynchronous framework. So we want to take full advantage of the capabilities and make our REST endpoints asynchronous. So we'll do pub async function list miners. And that's going to give us an HTTP response so we can use it in a response body. And we'll go ahead and define a to-do here. And we'll just say, get all miner DAO objects from DB and convert to miner objects. And I'm going to add this comment here for each of these endpoints. So as we go here, what I want to do, and just like for reference, I'm going to make this like, I don't know, like let miners, make it a vector of miners, and we'll set it equal to an empty vector just for now. Right, and we'll come back to that. But what this is going to return an HTTP response, we actually want to go ahead and make our lives easier here. So we're going to be doing this a lot. For every one of these endpoints, we're going to want to have some kind of HTTP response, like something that can be transferred over HTTP. So what we want to do is we're going to create this util file here, util.rs, and we'll obviously make that available here by doing create util all. And we're going to actually create some helpers in this class here. And we're going to use these for all of our endpoints. I'm going to go ahead and use Actix Web HTTP response because we're going to need that quite a bit. And also we're going to need our Saturday stuff. And here's what we're going to do. First, we're going to add this struct. And it's going to be a not found message. And so what we're going to do in here is just have a message that's just going to be a string. No big deal. And we're going to implement that. And that's how we will implement the new function on one of those. And now we'll go ahead and create this enum. And this is what's really going to make our lives easier. So we're going to do a generic enum of response type, and that's going to have three potential scenarios. We're either going to be okay, and we're going to pass a response body in there. We're going to have not found, and we're going to pass some kind of response body in there. or we're going to have created. And again, pass some kind of body through there. Now, as you can see, for not found, this is probably going to be this guy up here. But these other two are going to be different kind of structs, right? Like they could either be a miner or a wallet. So this is why we're using a generic here. And now this piece right here, we're going to implement on this generic, and we're going to make it only of serializable types. So only serializable structs can go in and out of here. And so we'll just make sure that we're implementing the response type. And this function here, getResponse, is going to be something that makes our lives easier in all of those endpoints. Here's where we're returning that HTTP response, right? So this function here, we're going to declare a variant of this enum, and then we're going to be able to run this getResponse and convert it to an HTTP response while passing in some kind of generic struct, which is going to obviously be one of these miner structs or one of these wallet structs. So this will come in handy. I'm going to type this thing out and we'll talk about what's going on. All right, so as you can see, we're going to just match on self, which is just going to be the type of variant that this thing is. So if we match on ourself and we're going to be an OK type variant, then we're going to convert our payload into this HTTP response, OK, which is going to be a 200, JSON type, and a JSON representation of the payload. And same thing for created. If we successfully create either object, miner or wallet, we're going to do the same thing. But this time it's going to be a created, which is a 201. So both of these line up. And then for not found, we don't have it as payload in here. I put it as message because I wanted it to be noted that we're going to use this a little bit differently. Instead, as you can see my IDE pointing out, we're going to be using this not found message struct instead. So all that we have as a response is just this one field. No big. But all right, so that's all we need to do in util. We're going to be able to use this getResponse function all over the place to build our endpoint responses. So if we flip back to the miner controller here, we are just about to add that right here. And what that looks like is going to be just this. Boom. And that's our return. So right now, miners is just an empty vector. But later, this is going to be all the miners we have in the database. And it's going to put them in a vector. And that vector is going to be our payload to our API. So we're going to reuse this capability right here a lot in all the rest of these endpoints. But all right, let's jump to our next one. We're going to get a miner by ID. So let me flip this thing out here and then we'll talk about what's going on. All right, so as you can see, we're just going to get the miner DAO object from the database where the ID is equal to the ID we're looking for. And that, of course, is going to take place up in our request, just like this. And that corresponds with our endpoint up here. And so what we want to do in this one, though, since we're searching and we're trying to match against an ID, like up here, if we don't find any miners, we can just return an empty vector. But here, if there's no match, we need to handle that, right? And that's where our not found stuff is going to come in handy. So let's implement a little bit of a match statement here. We'll first let miner, this time going to be an option of a miner. We'll set it equal to none, just for now. And we're going to match on miner. And if we get some miner, we're going to return that response type. Yeah. Okay. Miner get response. Nice. So that's pretty easy. If we get none, then of course we're going to do that response type not found. And now this thing's expecting a message. So we'll type this out here and then I'm going to drop this down to a new line so we can work. Now it's expecting a not found message struct. So we're just going to actually create that in line here. And that's why I wrote that new keyword, because this would be a little bit more slick to write. And boom, we're done there. So that's how we're going to do our handling of the match case if we don't get a match on this ID. But that'll look up a miner by ID. And now our last endpoint is going to be where we create a new miner. And now if you notice, we have to actually go through the wallets to create a new miner because each miner corresponds to a wallet. But we're going to implement that in the next video as we do the database stuff. So for now, you can just disregard that at the moment. And this is what our function is going to look like here. As you can see, we're going to create a new miner DAO object from the requested inputs and write it to the DB. I'm just going to set this equal to another empty vector now because it'll be easy to just like not get any errors from the compiler right now while we're just testing this thing out. And as you can see here, we're just going to do that created response from the util function. So now those are our 3 endpoints for the miner. And this is our actually completed miner controller. And now really quickly, I'm going to implement the wallet controller. And it's going to be pretty much the same thing for now. Just a shelled outline of what we're going to do. So I just dropped in all of our wallet endpoints here, and I didn't have you guys watch me type them out just because they're exactly the same, right? Like list and get both operate exactly the same. These are the same response types, the same match statement. We set it equal to none and an option. We did everything the same. And then when you create one, since we haven't implemented this yet, this one also looks exactly the same for now. But notice that because we created this generic here, like we got some nifty functionality here now with wallets and for miners, but using the same exact function and the same enum. So kind of cool. Some of our knowledge coming to fruition there. But all right, so this is all set to go. The final thing to do is going to be to actually set up our crate root here in main RS. So we're going to start by going with, we'll take this out here. So first thing is we're going to macro use. And the extern crate is going to be Actix Web. And that's a big one. And now our use statement here, we'll use Actix Web, middleware, app with a capital, and HTTP server. We'll also use std, env, and io. And we're going to add our mods now for each of our Rust files that we have in there. All right, so now that our mods are in there and this thing's going all red on me, we're finally going to add our Actix main function. You just do Actix RT main. And that's going to be our main function that drives this whole web API. And it's all going to be asynchronous. So again, we're going to make this async. And this is just going to be main. And by default, the Actix one wants you to return an IO result. All right, so now all we have to do is define our Actix application and boot it up. So this is kind of like a customary setup to start an Actix server. You usually want to set the Rust log level. And now here's where we actually will initialize the server. And that, folks, is how you start your Actix server. Now, with this configuration, this is how you turn it on by default, but there's no services in here. Like, Unfortunately, it doesn't automatically know what each of these endpoints are doing. So we actually have to tell it by adding a service. And that looks like this. And I'm going to go ahead and just paste all those in there. And so there's each of our services from the rest of the application. All right, now let's go ahead and run this thing. All right, now that took a while to run because this thing had to go in and pull all of those libraries for Actix, and that thing is a beast. But now that it finally finished and this application's running, you can see we're getting our debug messages from Actix. So this will tell you right here that Actix is online, and you can see it started up all the workers, and we're on localhost 9090. So let's go ahead and flip over to Postman and let's test those endpoints out. So we'll start by listing all the miners, and we get a 200 OK and an empty vector, just what we expected. Let's try to get a miner by ID. I'm not even going to bother putting an ID in here. Miner not found. There's our message from that not found message object that we created, and it's a 400, bad request. Same with wallets. Same by getting a wallet by ID. And then if we go to post, we get a 201 created, but still that empty vector because we didn't do anything yet. And the last one, bingo. So, as you can see, all of our endpoints are working great. Our HTTP responses are working. Our application is ready to go. Now in the next video, we're going to plug this thing into a database and we're going to bring it to life.